Realia has a significant role to play in the teaching learning process. Use of the Realia initially rivets the attention of the students because they want to know how simple things around them can be used for teaching learning process. And in the process, the learning gets riveted, learning gets reinforced. The video that we are having here shows how Realia could be used to capital purpose. Good afternoon, students. Digan Karadi, are you there? Digan Karadi. There he is. Are you able to hear me? Good afternoon. Are you able to hear me well? Okay, great. Now, Karadi, Digant, let's start with you. Tell me what is the work what I gave you and what you have done.
A boat or a ship floats on any fluid.
And then I gave you two expressions. What are they? Flotation, specific. You wrote it.
Flotation and specific gravity.
Right.
Yes, sir.
Flotation and specific gravity. This is the title, major title which you are given. Now, others who introduce yourself.
And all my dear friends, my name is Digant Karadi. I study in class 10 there and I belong to Kaveri House.
Okay, others. One by
Good
one.
morning, Principal Sir, and all my dear friends. My name is Disha Takmadikar. I study in class 10 and I belong to Durga House.
Very good. The other fellow.
Good morning, respected Principal Sir and my friends. My name is Palpati. I study in class 10th and I belong to Kaveri House.
Very good. Did you coordinate it well to answer the question which I asked you, Digan?
Sir, actually the coordinator and you told us that you will explain the other two fellow also that what we have to do exactly and you will tell them how to work.
Very good. That means you want a briefing right now. You want a briefing
Yes.
regarding what exactly I meant and what I want you to do. Okay, very good. Now, if you see, this is what it is. Are you able to see this? Are you able to see this?
Yes, sir.
It's a paperweight, okay? It's a paperweight. Suppose I put this paperweight in a glass of water, what would happen? I want an answer.
Yes, sir.
You have to react, you have to answer.
Yes, sir.
It will sink. Say the weight of this is, let's say, is about 100 grams. It won't be more than 100 grams, the weight of this. Now you take a ship. A ship may weigh, the total weight of a liner ship will weigh anywhere around 7,000 tons, 8,000 tons. Lorry ships, which are all may weigh about 7,000, 8,000 tons. But it floats in water. Am I right? It floats in water. A 200 grams, a 100 grams weight, if you put it in water or if you put it in any liquid, it sinks. But a ship which is weighing around 7,000 to 8,000 tons, it is floating in water. What must be the reason? What must be the reason? This girl, what must be the reason?
Sir, depending on the density.
What's the connection between density and flotation? This is what we call technically buoyancy also. What's the connection? You are right. Density has a role to play. Do you know how to swim? You know how to swim?
Yes, sir.
Do you know how to swim?
Yes, sir.
So when you swim, what happens? The difference between a person who does not know how to swim, a person who knows swim, okay? When both of them jump into water, what happens? A person who doesn't know how to swim, he sinks. Am I right? A person who knows how to swim, he keeps afloat. he is able to keep his head above the surface of water so that he can breathe well. What is the difference between the two? Why is it happening with a person to swim? He is able to do that, and a person who does not know swim, he sinks. What's the facility to help him? Yes, he moves his hand like this, right? And moves his hand and the leg. How does it help him to keep afloat? Okay, I'll reframe my question. Have you ever drawn water from a well? Have you seen a well?
Yes.
Normally when you get water from a well, we put a pulley there, and then you have a rope or a chain. At the end of it, the bucket is there. You allow the bucket to go inside. Am I right? Have you seen it? Have you seen it? And the bucket gets filled with water. Okay, when the bucket gets filled with water, the bucket gets inside the water. Am I right? The bucket gets inside the water. Suppose depending on the depth of the well is, let's say, about 20 feet deep. Then the water goes inside, the bucket goes inside. As long as the length of your rope is there, then you start pulling it. When you start pulling it, you feel the weight to be lesser. You see the weight to be lesser. But when the bucket gets out of the surface of the water, you feel it to be heavier. Have you ever felt it? Have you ever seen it?
Yes, sir.
So why does it happen?
Sir, it is because of the upthrust of the water inside the water.
That means when the bucket goes inside the water, you say the water gives an upward thrust. Why does the water give upward thrust? Why does it give upward thrust? Suppose you have a glass of water. Let's say a glass of water. Let's say the total volume of the water inside the glass is, let's say, is about 200 ml. Okay, and let us say this paper weight, its volume, let's say, is about 75 ml. If I put it into the water, what will happen? It will sink. Am I right? When it sinks, what does it do? It will occupy space inside the water. Am I right? If its volume is 75 ml, 75 cc, its volume is 75 cc. There are 200 cc of water, cubic centimeter of water in the glass, and I put it in, and it sinks. When it sinks, what will happen? It will occupy space inside the water equivalent to 75 cc. Am I right? Now what the answer? I don't know.
Yes, sir.
When it occupies 75 cc of water space inside the container, then there must be water in that 75 cc area also. Am I right?
Yes, sir.
And what will that water do? The water will move up. Am I right? That's what you see.
Yes, sir.
That's what you see in a glass. Is it possible to get a glass? It gives an upward thrust to the body. You see, are you able to? What चाहिए?
कोई एडमिट मांग रहा है स्नेह पटेल
पूरा भर दे हाँ बस You see, are you able to see the glass of water here? Are you able to see?
Yes, sir.
This is glass.
Yes, sir.
And you see the level of water. I put it inside. Now, are you able to see the glass? Are you able to see the glass?
No, sir.
Now?
No, sir.
Are you able to see the glass?
Yes, sir.
Yes.
Okay. Now, I am going to put this into the water. What happens to the level of water? Are you able to see the level of
It
water?
comes up. Yes, sir.
Yes, sir.
Originally, water was only up to this level, but when I put it in, what happened? The water level moves up. Why does the water level move up?
Sir, because the space which was earlier occupied by water is now occupied by the...
Just see here. Are you able to see it now? Inside, are you able to see the paper weight also?
Yes, sir.
Are you able to see the paper weight? Yes?
Yes, sir.
Ah.
Yes, sir.
The moment the paper weight, Kinjan, इसको निकाल को paper weight निकाल.
Yes, sir. It's above half.
Above half. Okay. Now I am going to put this paper weight. Are you able to see the paper weight in my hand?
Yes, sir.
Yes.
Okay. And now the water is a little above half. Am I right? I am going to put it into the water. Yes. What's the water level now? What's the level of water? It is almost 75%. It is almost 3/4. What was originally half, now water level has increased. Have I added water into that? Did I add water into that? I did add water. What I did was I put a paperweight into that. Though paperweight went inside, it has to occupy some space, right? Assuming that the weight of the volume of the paperweight is 75 cc, am I right? And the paperweight goes and occupies 75 cc cubic centimeter of space, and obviously the water in that spot is moves up because it displaces the water, am I right? The paperweight has to go and sit inside the glass. The water in that space has got to be displaced. When it displaces upward because there is no this side it cannot move because it is all covered by glass. So upward it moves. Are you able to see and have you understood what I said? I said when you put a solid into a liquid, if the solid sinks in the liquid level moves up. It appears as if there is more water in it now. Though technically there is no more water, same water. But it appears I have gotten more water. Am I right or wrong?
Yes, sir.
I am right?
Yes, sir.
Okay. Now, if the water moves up, keep it there. Let it be there. If the water moves up, that means 75 cc of water moves up. Am I right? When it moves up, what will it do? Suppose I move.
It will give upward flow.
That's all. When I raise my hand from here, then what do? I give an upward thrust to the air. Am I right? When I raise my hand.
Yes, sir.
Similarly, the 75 cc of water moves up. What does it do? It gives an upward thrust. And the upward thrust, the force of the upward thrust. What will be the force of the upward thrust? The force, because the weight of the volume of the paperweight is 75 cc. When I put it in, it will displace how much? 75 cc of water. And the 75 cc of water, when it moves up, it is going to give an upward thrust. And what will be the force of the upward thrust? The force of the upward thrust will be equivalent to the weight of the water. Am I right? If you take 75 cc of water and weight, what will be the weight? That weight will be the force with which it will give an upward thrust. Am I clear? Or you have any question?
Yes, sir.
Am I clear? You have any queries?
Yes, sir.
You have any queries? Any queries? Clear? Yes or no?
Yes.
Okay.
Yes, sir, clear.
Okay. Now, let us see flotation in water first. I will tell you about the flotation in air later, but flotation in water now. Liquid now. When you put a solid into a liquid, there are three possibilities. One, it sinks into the liquid. Second, it floats in the liquid in the way part of it is inside the liquid and part of it above the surface of the liquid. The third one is it is at rest in the liquid. That means, have you ever seen a plastic mug? You are using the plastic mug now. Suppose you fill a bucket of water and put the plastic mug into the water. What will happen? The mug will float. Am I right? It will be floating. Suppose you fill it fully with water and put it inside. Then what will happen?
It will sink.
It will sink to the bottom of the bucket, or it will be floating up so that the surface of the water and the top surface of the mug will be the same.
So it will be on the top surface, the amount of water which is filled in the mug, that will be sinking.
Okay. So that means when you put a solid into a liquid, there are three possibilities. One, the solid sinks into the water. It goes and settles down at the bottom. Second one is It doesn't settle down in the bottom, but it keeps floating, but it's still fully, the entire part is inside the liquid, and the top surface of the solid and the top surface of the liquid, they remain the same. Third one is, part of the solid is above the surface of the water and part of it is below the surface of the water. Am I right? Have you understood it?
Yes, sir.
How many of you have traveled by a boat? Have you traveled by a boat? You have not traveled by a boat. You have traveled by a boat. See, when the boat is empty, boat is put in water, little part of it will be inside the water. But as people get, more and more people get, the boat gradually sinks into water. Have you seen it? Am I right?
Yes,
Okay. That means it sinks till such time when the water displaced by the sunk part of the boat, the weight is equivalent to the entire boat. The boat and the people inside. Am I right? Am I right?
yes, sir.
Okay.
Yes.
So that means an object, a solid, floats in a liquid when the weight of the solid is equivalent to the weight of the liquid it displaces. Are you able to understand what I said?
Yes.
Right.
Yes, sir.
When the weight of the solid is greater than the weight of the liquid it displaces, it sinks. Am I right?
Yes.
Two things I told you. Try to understand the philosophy. When the weight of the solid is less than the weight of the liquid it displaces, it floats. Am I right? Yes or no?
Yes, sir.
Okay. When the weight of the solid is more than the weight of the water or liquid it displaces, the solid sinks. Am I right?
Yes.
Yes, sir.
Okay. The third category is when the weight of the body is exactly equivalent to the weight of the liquid it displaces, then it will be at rest in water. That means it will be entirely sunk in water, but it will not go deep down onto the bottom. Alright? The top surface of the water and surface of the solid will be the same. That's what happens with a plastic mug. If you are not done it, do it today. Take a bucket of water, go and put a plastic mug. First, when you put it, the mug will float fully out. The entire mug will be on the surface of the water. You fill it with water, the mug will sink. When you fully fill it with water, the mug will be under the surface of the water, entire mug. But the mug will not go down and settle down in the flow, at the bottom of the bucket. The mug will be still floating. The soft surface of the water and the top surface of the mug will be the same. Have you understood what I said?
Yes.
Yes, sir.
Yes, sir.
Now what you do today, I am going to stop you only in this. I will once again talk to you. Tomorrow I will give a call to you. I will once again talk to you about flotation in air. Flotation in water, flotation in liquid takes place on three possible grounds. One, if the solid which is thrown into the liquid, if the weight of it is more than the weight of the liquid displaces, it sinks. That means it goes to the bottom of the container. Okay? If the weight of the liquid displaced is exactly equivalent to the weight of the object, then it remains at rest in water. That is the experiment I told you about the plastic mug. You can try it at home. And third one is, if the liquid displaced, the weight of the liquid displaced is more than the weight of the entire body, then the body floats. Am I right? Right or wrong? These three principles. Then we will come to the question of density. What's the connection between density and flotation? But right now you write these three principles. The principle of flotation in liquid. If the weight of the solid is less than the weight of the liquid displaces, it floats. If the weight of the solid body is more than the weight of the liquid displaces, it sinks. It goes and settles down at the bottom of the container. If the weight of the body is exactly equivalent to the weight of the liquid it displaces, it remains at rest on the surface of the water. Am I right? Am I clear or not?
Yes, sir.
Yes.
Yes, sir.
Now what you do is you write these three principles in words of your own. Number one. Number two, take to the testing of taking a bucket of water and take a plastic mug and just put it first. The entire mug will be on the surface of the water. You gradually fill it with water. When you fill it with water, gradually the mug will sink. When you fully fill it with water, the mug will not go down and settle down on the surface, on the bottom or the floor of the bucket. It will be floating, but the entire mug will be inside the water. And the top surface of the mug and the surface of the water will be more or less the same. My points are clear? Clear?
Yes, sir.
Test this today. Test this today. We will meet once again after the 15th of August. Probably after 15th of August, things become. Will that be okay for you? Will that be?
Yes, sir.
Okay. So today you should do the test, the experiment which I told you with the bucket and plastic bag. Please do it, and rest we will see. Ramesh Sharmaji will give you a call regarding the next meeting. Okay? Sure. All the best. But most important thing is you must write down these three principles. Principle of flotation which I told you, write it down. The relationship between the object and the weight of the liquid displaces. Okay? Am I right?
Yes, sir.
Okay. All the best. Finish today and go ahead, and we will meet once again after the 15th of August. Okay? God bless you. Ciao.
Yes, sir.
Ciao.